Hi everyone. Hi Ashna, welcome. Can you hear me?
Yes. Hi, just give me 2 more minutes.
No
I have
problem.
some technical problems. Sorry.
No problem. Yeah. That's fine.
Yes, hello.
Hi Ashna.
Hi.
So, how are you?
Good.
Good.
The change is not so good.
Yeah, it might be very cold here
Yeah.
in Germany. Here it's already like 4 or 6 degrees.
Yeah, right now we have 4 degrees here, so
Oh, good. That I could see you are in your warm
oh yes.
clothes. I see. So then, how do you work in your observatory?
In the night, so next week when I'm observing, it's already -2.
Mm-hmm, mm-hmm,
So with lots of coffee, of course, because it's a full night and with
mm-hmm.
lots of jacket. And now, thanks to technology, we don't have to work all the time in the cold. So we have
Mm-hmm,
to just go upstairs for like
mm-hmm,
just opening the telescope, and then we can go down to our control room and work
mm-hmm,
from there.
mm-hmm. Oh, that's really good, I
Yeah.
would say. In the heaters. I see. Great. Then now, so welcome everyone and welcome Ashna as well to our side chat. That is episode 5 that today we would be doing. So basically, it would be like exoplanets and talking about telescopes and something that is life outside our planet, that is Earth, and much more. We would like try to extract whatever we could from Ashna about from her study of last few years of PhD and also masters. And yeah, so Ashna currently is doing her PhD at TLS in Germany. It's a very good observatory, and it's in Jena, which is like near Frankfurt, like center of the Germany. Not ideally, but kind of, yeah, the kind of center in the Germany. So I think she will introduce herself more, and she would talk about herself more, and then yeah, that's how maybe we could just proceed. So Ashna, all yours.
Okay, thank you very much. So, hi, welcome you all, guys. Good morning for us, good afternoon for you all, or it's still good morning for all of you, even in India. Happy Navratri. I'm a big fan of Navratri, so yeah. And hi, Ashna, I am a PhD student affiliated with University of Vienna. I mainly work here at the observatory. at Germany. We have a 2-meter telescope. And I observe with that my main PhD topic is to upgrade our 2-meter telescope with optical fiber and then do the observations to find these exoplanets. That is already like follow-up observations of TESS. More about TESS I will be talking about in a later phase. And I did my bachelor's and the first master's from India. And then I came here in Germany to do my master's in astronomy and astrophysics. Sorry, in Potsdam, and there I did my master thesis with cataclysmic variables. No need to go in detail. It's something that our sun will die and it will become a white dwarf. So the similar kind of a stars.
Mhm.
I worked with on that. Then I also worked as a research assistant in Kiel University. There also I was working with the exoplanet to find the exoplanet atmosphere, mainly a simulation work and the coding work. And then I joined here as a PhD student and working for astronomical instrumentation and observations.
That's, I would say that's really good. So you mentioned about the white dwarf. So maybe we would go into it gradually when we discuss what it is.
That's again completely different topic than exoplanets.
So
So
maybe another site at someday.
yes, yes,
Sure, sure. Okay. So for now, let's stick to the whatever our theme is. Okay.
that's better.
So let's not much waste our time in like talking because everyone has very tight schedules. I understand. So let's start with uh, what do you think that what is like life outside Earth? How do you imagine it, or how do you see into it that okay, when someone tells you life outside Earth, for us it's like very simple, having some organism maybe or some biological or inorganic or organic molecules out there. And I mean that's how for us is the life outside Earth or possibility of life. But you as an astronomist, how do you see life outside Earth?
For us also it's the same because we also like humans. We are also astrophysicists are also social animals. Mainly for us, life outside Earth means something living object that we can like say that okay, it is breathing, it is like movable, something. So yes, of course, I want to believe in a positive way, and you can't say that there is none other than us because it's kind of stupid. Because every star in our galaxy is at least one planet. So our universe is so big. So we might have one. It's just that we are not able to find yet, or they don't want to contact us, or we are very dumb, or something like that. So this is the case. So we really don't know whether it's there or not. So of course, scientists always, when there is no proof, we always go for like yes, there may be not. We are searching for it.
I see. So it's like they are also looking for us, and we are also looking
Maybe,
for
maybe
them.
you never know. I'm a big fan of science fiction and all that novels and movies and all that. So maybe
Mhm,
why not?
mhm, mhm, mhm,
It's
mhm.
always this UFO just came on Netflix and I was just looking at yesterday only the intro. And it's like, yes, they were not, they don't want to contact us or they are not contacting us. So it's the same other way around. We are
Yeah,
still not able to find with our techniques
yeah,
whether they are there or not. But
yeah,
then we can't say that it's not there. It's
yeah.
just that we yet don't know. Same like a biology. Something is not there doesn't mean that
Mhm.
it's not exist or something like that.
Yeah, yeah, yeah. Absolutely. Maybe few million thousand years back, also Earth didn't exist, and maybe some other planet in our solar system might have some life at that time. So yeah. I completely agree on this point that like we cannot be the only one.
Yeah.
That is that is very rare
Like, I
possibility.
don't want to believe in that kind of theory that we are the only one kind, because yeah, it's like probability wise also, if you think also, statistically, mathematically, it
Mhm.
seems kind of impossible that we are only one. It's yeah,
Yeah, yeah. Because the universe is like expanding. I would say on the speed of our thought,
every day.
and
So
even
like, you
yeah,
were seeing yesterday universe, it's not the same as today. So it's
yeah.
already expanded.
Yeah, yeah. Even that we discussed the other day that okay, if there is some star which is considered 1,000 or maybe considered one light year also ahead, then ideally I'm looking at that star one which was originally 1 year back. So I completely agree on this. Uh, so now moving ahead a bit, that you look for something which is like moving, you said that, or there is some signal that okay, there is some uh, activity that is going on. So can you break this down, that what kind of activities you look for exactly?
Okay, so the first thing is we want to look for a biosignatures. But for that, first we need to find out the exoplanet. And there
Okay,
comes this. First, we
okay.
need some ground like a Earth
Mhm.
where we can find the biosignatures on that particular planet.
Okay, so first you try to get information of exoplanets and then
Exactly.
find some biosignatures.
Exactly. Then we go and just focus on that particular planet,
Mm-hmm. Mm-hmm.
and then find properties of that particular planet. Like our
Mm-hmm.
Earth also has this greenhouse effect,
Mm-hmm. Mm-hmm.
like
Yeah, yeah.
liquid water, everything. Without that, we cannot survive. So to have some kind of a perfect atmosphere for any living creature, whatever it's amoeba or XYZ or anything. So for that we need this.
Yeah, I see. That is really good, I would say. So how do you go ahead in the exoplanet? Like, can you cut it down? That okay, first, what is the first step? Very first step that you look. Okay, there is a like dark sky, and then what are like? How do you just go for that? Okay, how do you judge? Okay, this is exoplanet. This is exoplanet.
Okay, so in a very simple language, exoplanet means it's like exo, like planet means okay, something that is like Earth or something like that. I will not say Earth, then I will say Earth like planets. But something that is just orbiting around one star. So already all of us know that Sun is our star. So similar like that what we found something planet kind of object around star is known as exoplanets. And for that also you have to go in very much of detail, like how can you find this particular object? And for that you have lots of method for it.
I see. I see. So you go. So something which has atmosphere, I would say.
You can okay, so in exoplanet also we have lots of how to say types also. So it's
Mhm.
always not like that this particular kind of, we have this rocky planets means it's full of the rocks. We have some gaseous planets like Jupiter and Saturn.
Mhm.
So this different kind of exoplanets we have in our solar, in not in our solar system, in our galaxy and also outside of our galaxy.
Hmm. Hmm.
So also some people say this extra solar planet, but it's the same as exoplanet. So we don't have to confuse between extra solar is different than exoplanet. No, it's the same. It's just
Okay.
that planet orbiting around a star.
Okay. Okay. So you mean extraterrestrial planet,
That is
or
also the same.
that is also the same?
That is also the same.
Okay. 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 That is so extraterrestrial planets, or you say exoplanet.
Extrasolar planet or exoplanets. It's this only where the planet which is not belong to our solar system is known as
Mhm.
exoplanets. Very simple.
Okay. That's it. That's it. Okay.
That's
Okay.
all.
Okay. So this is what is solar exoplanet, and then uh, how do you go ahead in getting some biosignatures? Because uh, uh, what differences especially you uh, mark for that? Okay, this is a exoplanet and this is not. Like, consider Jupiter, it's not an exoplanet. You can, there is
Yes.
no, I
Because
don't
it is
know.
in our solar system. I already saw one that can
Ah,
we go Pluto as an exoplanet? No, it's not.
no, yeah, I see.
It's a
So
it's a draft planet.
yeah, because it's in the Kepler belt or something like that, right?
Exactly, exactly. And the also thing is that this exoplanets is like orbiting around the other star than our sun.
Mm-hmm, mm-hmm.
That is also called as an exoplanet. So even in like whatever we find these exoplanets,
Hmm.
they are orbiting around different kind of a stars, not our sun.
Not our sun. I see.
So
I
that
see.
is also one thing. Okay, when you are saying that this biosignatures and all that. So
Yeah.
first, when you find this, that okay, how to find these exoplanets? As you said, you just look at the sky and oh, okay, this is exoplanet. No, this is not okay. This is also one method called direct imaging, but it's very very rare. With this method, you can find exoplanet. Mainly, you have to go with the indirect method, which is like transit method. Means our star is here. Is anybody like see my hands or it's still like I
Yeah,
think
we could see your hands.
yeah
Yeah.
okay.
Yes, yes.
So it's like a star here and so orbiting the planet is orbiting around here. So like a eclipse. So yesterday eclipse happened. So when the planet is just going in front of a star, when you take this data, you can see the dip and then
Okay.
we can say that okay, this particular system has exoplanet.
I would like to ask that
Sure.
it is the only criteria through which we can call it exoplanet, or there are different kind of materials which are required to be like the planet which is made up of. So there are
For
criteria.
exoplanet, you can say that any planet can be exoplanet. But then we have this criteria like Earth-like planets, Jupiter-like planets. From the name itself, you can just say
Yeah.
that Earth-like planets means it's like a Earth. And then also it comes out when you are talking about life, then it comes out about habitable zone. Means
Okay.
there is atmosphere exactly like a Earth, not too hot, not too cold, not around our like sun like star, but maybe around a different star. But are we getting a same kind of atmosphere like properties or not? So then it comes to this habitable zone, exoplanets. So exoplanet it's general it's like a humans. We all are humans. Or like let's say about I'm feeling hungry. It's on my breakfast time. So let's say it's our recipes. So recipes in general, you can just call it food. But then you go down little bit to Italian cuisine, or you go down to Indian cuisine, like that. So this kind of
So,
thing, it's like Earth-like planets or like this, similar.
so what do you think? Why is the exoplanet study important?
Okay, that's a
How?
good question. So
Yeah.
first is very like for me also, still I still believe that we are not alone. So for that also, we need to find the exoplanet. Also, one more very to gain an audience, and also I personally also believe that we are actually screwing up our own Earth. So climate change is real for sure. So for that also, we need to find out something else. And the third, it's not always about to looking for someone or something. From this kind of exoplanet studies, you can always find out that how they made. From that, you can find out that's how this universe made of, or how this happened in the past. So from these properties also, sometimes we can get ideas for our own Earth. So that's why also exoplanet
Okay.
needed. And to find this exoplanet, we need to come up with the instruments. Those instruments are not only useful in this industry, but also in our day-to-day life industry. So in that purpose also, it is very important.
So, like, how can we replicate these studies, like the atmosphere present in exoplanets, which can be used to mitigate climate change on Earth? Jesus.
Hmm, you okay? You can't actually like replicate or something. That is very.
Like
I would say that.
how can that study be helpful? Like
Yeah. Okay, you can say that this particular planet so far, let's see that we found something and it's coming in habitable zone. Habitable zone means which is not too hot, not too cold, kind. It's good to live and all that. Then
yeah,
it's not only the case. Then we have to go and search for other things. Like, do they have carbon? Do they have this greenhouse effect? It like, can
correct.
we go plants over that? So this all stuff we need to study, and that's why this is important. If I am like understanding your question correctly.
Yes, yes, yes. So we have one question that for the indirect method you said the exoplanet corresponding to stars and us need to be in same like plane.
Yes, yes, and it depends upon which kind of indirect method are you using. You are using radial velocity method, which is like spectroscopy. So everybody studied about this Doppler shift, like ambulance, silence, siren coming towards us or going away from us. So that same concept we are using in this radial velocity method.
Okay.
Sure. So in this two is like this transit method. Yes, you need in one plane only. Then only you can see that this is eclipsing. Then we can find a dip with the telescope, and then we can say, oh, okay, here there is a dip. Means there is something here. What is something here? Then we go for this different method. It's called radial velocity method. Means when these two are orbiting, it's not like that star is fixed. Star is also moving, and planet
Yeah,
around us is also moving, because universal center is something different. Like our sun is also rotating.
yeah,
So like that, it is rotating, and when the star is coming towards us, towards our observers plane, you can see in this spectrum that okay, this is this particular line, inspector line in our spectrum is coming towards us, means blue shifted, we call it as a blue shifted, mean coming towards us. Then we can see, okay, there is something and there is some change in here. Again it's going away. Again we can see that it's red shifted, and also we can find that, oh, this particular line is, it's shifting a bit, only one particular line. From this both study, we can find the mass of this particular planet. This is how we study. And this is, again,
Oh,
I'm just saying in a very basic way, because it's not as simple as I'm talking.
mhm.
Because it's
Regarding the
always
mass
I
calculation,
see.
so many lines are present in a spectrum.
so regarding the mass calculation, it went too fast. Can you talk about
Sorry?
it once? Regarding the mass calculation, I couldn't really follow through. Can you explain that?
Yeah, okay, okay. So yeah, sure. So from this spectrum, you can see the
Okay,
radial
okay, wait,
velocity.
wait, wait.
Radius is
Ashna, sorry to cut. Sorry to cut. Okay, first explain which spectrum. I or someone who is not in the physics cannot understand what spectrum dip you are talking about. I mean, I was just
okay, okay.
confused. Okay,
That's very good
we have
question. Yes, my
spectrum,
bad.
but there are like thousands of spectrum. So which
Yeah, okay.
spectrum are you
My
talking
bad.
about?
Okay. So like a star, let's say it's one body. Every human body is different. Every human characteristic is different. I have a specs. I have a long hair. Like this, every star contains different information. To find this different information, you need a spectroscopy of that particular object. How you do these spectroscopies? You just use a prism and all that in the telescope. I will not go into much detail of that, because then it will like another like topic of this. So from this telescope technicalities, just in a basic way, you can get this spectrum. Means this is particular one star's characteristics. Spectrum means nothing but it's like a property of a star or property of an object.
So
So
would it be
every
correct to
Okay.
yeah.
would it be correct to say that you're just looking at the frequency distribution in the light coming from that star, assuming
Yes, you can say like that. Yes. Yeah.
okay.
Yes, you
Okay. So
can
there
you
are
can
different types of Okay, so there are different types of frequencies that you are looking for. Maybe it light, maybe it's something like weight or mass or gravitational, or maybe something else, or maybe this, or maybe that. So, like combining all these different types of frequencies, did you call as a specific spectra or
So
spectrum of that planet, a specific, which is like
so
a characteristic
so
for that?
there will
if
be the
if
spectrum
we
of the star, not the planet. Because
No,
of the
sorry.
planet,
I mean the planet. Sorry.
yeah.
Yeah, I mean the planet. I'm in the planet. Sorry. Okay. Yeah. Now I
so
think
so
Himanshu's question, you could go
yeah,
ahead.
I have one more question. So sorry, I'm like hogging up all the time.
All good.
So yeah, so for the gravitational spectra of a planet, well, this is well, what kind of distribution it will be? It will be just
I will
one,
not say that it will be a gravitational spectrum. It will be just a
yeah,
spectrum. That's just containing information,
right?
like
Just
this
a
particular
force of
wavelength
attraction.
information. Simple.
This
Gravitational
graph,
spectra is completely then. I will not say that it's correct also to say this gravitational spectra,
yeah, I felt this.
because
Yeah,
it's, I don't see this term exist for me.
yeah,
But
doesn't
I
make
don't want to
sense.
cut it, because it is for me also. It is also kind of first time where I am explaining my subject in a um, public outreach way. So you can say that this is just information, as you said, just giving in particular lines. So it's like we have a iron line in the spectra. We have say carbon line or something like that. So in spectrum, you can just say that we have this lines, nothing else. But when you say this spectrum comes with certain lines, then one particular line is moving towards us or going away from us. That shift, we have to calculate that shift. And from that shift, then also from this transiting method, we have this dip. So we have also distance of that. From this calculation, we can find a mass of that particular planet. How much shift is it happening? You can say it's a Doppler shift.
So for the Doppler shift for different frequencies, assuming light spectra, it varies. So they correspond to the elements, right? So that varies for different elements.
That will vary as
Technically,
per the different also element, also the as per the planet, how the planet is associated with that particular star.
okay.
Because when this is like this is star, this is planet, and they are just moving. So it's always not like that it's only one planet. They might have two planets. So then in when you looking at this star spectrum, you see some sudden shift of this line coming towards us, but then there is one more line shifting towards us. So then it's like, okay, how this is happening? So these two
Ah,
shifts are associated with the star planet movement, so to say.
Interaction.
Yeah, interaction.
okay.
Thanks, man. I was missing out that word.
So I would quickly, sorry, Himanshu, I will just quickly break this down for others who are like non-physicists, like me as well. So consider that the planet has a moon. So then, how do you differentiate between these two? That okay, this is from some other planet, and this is not from the one that we are looking for, or maybe this is from the moon.
That is
Because
also
let
very
me
good
complete.
question. Yes,
Okay,
continue.
just let me complete. So we are looking from a very far side, very far side. So maybe that could be possible. I'm not a physicist, nor I have been into like high resolution telescope. But what I know from the basic knowledge of optics and microscopy, that there comes a point of sightedness where two objects look the same, which is also called the resolution of that, right? So at that point, maybe it could be possible that you could also see them together. That okay, it's the same. So how do you differentiate between that to that? Because they are in very close proximity with each other, at least with respect to us.
Exactly, very good. And that was also one of my previous project where I was doing the falsify of these exoplanets. And that's why I will say that we don't have so many habitable exoplanets. We just have exoplanets. People come and people just find these exoplanets. But always is not the case. Even in the spectra, not only this, we sometimes also find, if we are observing from Earth, we sometimes find the some spectral lines which is from the Earth atmosphere, or some satellite is moving or something like that. So that is, we can't actually say that, oh no, we just found this exoplanet. No, we have to go through so many other like checking. Okay, with this is happening. The same like this, this gravitational wave finding they did in the LIGO. You can't just say that, okay, something is coming. Oh, we found. No, you have to go and check with other methods also, that whether it's actually a planet signal or it's something false signal. And trust me, even right now also in the science also, we have so many kind of these planets which are like, they already like say that this is a planet but it's not a planet, and one a whole community is researching on that to disqualify this kind of planets who are not planets. That's just a falsify signal in a spectrum. So when you do this research, it's not always like, okay, it's a shifting, oh, I found a planet. No, you have to go and you have to check with the other methods, with the other space-based telescope, ground-based telescope, and then confirm whether it's exoplanet or not. Or you can just publish your work also. Sometimes it's get accepted, but then the other community will come and say that no, you were wrong, this planet was never there, it was a false signal and all that. So we have so many cases of this. So that's why it's work like that. Or sometimes it's
So
work like that also, that first we found the two planets, like one of my colleague recently found this, and then she found a third planet which is ultra short period exoplanet. It's just 7.7 hours orbiting around the star. So far the study was, they were saying that okay, this particular star has two planets, and then she found out a third one, and it's like wow, because it's containing iron core, and iron core means everybody knows why it is important. Anybody can say?
Mars?
No, it's because of Earth, iron core.
I see.
Magnetic field, atmosphere.
Sorry.
So iron core, then it will have a magnetic field, and that could protect us from.
Exactly. So now it's just that they found an iron core. They found its ultra short period. So they were very much like excited. They have this press release also. You can go and just search for it. And it was, yeah, very recent work, just like a month back or like 2 weeks back or something like that. So now they are going much into that detail. So the thing is that system was already there. So see, this is the live example. System was already there. Two planets were already there. And nobody was like, yeah, okay. And she was doing this analysis and she found this signal. And she also was like, no, I'm doing something wrong, because we all struggle with this imposter syndrome. And then her supervisor told that no, there is something interesting. And then we found out this. So,
so
yeah.
how did they find out iron? So like,
Sorry?
how did you know that the exoplanet has iron in it? What study led to it?
I'm sorry. Can you please repeat? Your
So
voice is breaking. I'm sorry.
So I
So
maybe I think I understood the question. She's curious that how did you find out that there is iron?
Okay. So again, we need to do this spectroscopy. So they found this one particular system with the test transiting exoplanet science survey. Then they did this observation with the HAPS, which is in like a Chile. They have this HAPS spectrograph. With that,
Okay.
they did a spectroscopy studies, and then they found out these properties of this particular exoplanet. So her first task was she just detected this third particular signal. Then they first confirmed that, yeah, okay, this seems to be exoplanet. It's not a false signal or something like that. So when they confirmed this, then she went into a further detail with this spectroscopy and find out the properties of that particular planet.
Okay, so what specific spectra do you look for at that time? Like, is it something at specific wavelength, like at maybe infrared or near infrared or X-ray?
HAPS is working in optical range, but she also studied a near infrared studies with that. But that I need to confirm with her studies. But mainly she worked with the optical range with 300 to 650 nanometer.
Oh, I see, I see. So whatever information you are getting usually with the optical range
Yeah,
is
it
more.
depends. It depends. It's not like
Okay.
always. Like I work in optical, but she work in near infrared and optical. But some work in X-ray as well. I worked in the past with the X-ray, so it depends.
Ah,
Like this
okay, okay.
JWST, it's mainly working on near infrared.
What is AWST?
JWST, this NASA's the Webb telescope, James Webb telescope, the space
Oh,
based telescope that is like searching also like for like exoplanet, also the other studies as well. But in that spectrum also they like in these studies with this telescope they also come up with this, okay, with this in the space we found out this exoplanet and this may contain a water kind of signature and all that. But then science community came up, and when they checked this James Webb telescope, this particular one object, they found out that, oh no, there is some faulty like that. But this particular James Webb telescope is working in near infrared, so it depends upon which wavelength range you want to cover.
So
Mainly
how
from the
is it?
ground based, you can do for like near infrared and optical.
Yeah. How do you decide on what wavelength you want to study?
It depends upon your project and your supervisor and your funding. Nothing to do with science, man.
so optical.
It's not always the science.
I suppose that working in the optical range would be a bit cheaper and convenient as well.
Yes, because come on, it's a ground-based telescope, so of course, ground-based is way more cheaper than space-based. And also in space-based, it's like, okay, if you work also with this, you have to propose your proposal. Then the chances to get selected that this particular proposal is like way more less. And that you have so many of like competitors, because you only get certain period of time. If you don't publish your work by that time, it will be public and all can see the data. And yeah, it's just like that. So it's very competitive field where you have to like be on like, okay, so though science is not work like that, but unfortunately nowadays science works like
So how can you give us some lights on how telescopes are helpful for the exoplanet study and what kind of telescopes can be considered?
that. Sure. So in general, like if you want to observe the outside, like space or something, you need a telescope. That's very basic for sure. Or if you want to see the Saturn rings also or something, or like craters on the moon, or Chandrayaan 3 or like latest, you need a telescope. No, just kidding, but yeah. Okay, so this telescope is mainly like ground based, space based we need for certain wavelengths like x-rays and all that we cannot observe from the ground waves because of the earth atmosphere. This particular light will not pass through our wavelength, our sorry, earth atmosphere. So for that we need space based. Of course they are way more expensive, so we need something on ground also as well. This telescope works with different wavelength, so we can say that, okay, we confirm first with the ground that there are something. But from earth also because of still our limitations, we cannot see like perfectly, like very nicely, as like Dhairya said that you might find two objects as the same. So that might happen because of the Earth atmosphere. Sometimes we see that, oh, we found this water signal, but it's just the water vapor of the Earth atmosphere, not from the exoplanet. Yeah, there was a case. Like they were like so excited, and then they found, oh no, there's just water vapor from the Earth. So this is like that. That's why we need ground-based telescope, and that's why we are just upgrading our telescope with this optical fiber technology. So it's like, I don't know in your physics chapter it was coming, but in my time, in my textbook, it was always like that for this nanotechnology, that bigger is better. It's not true all the time. So we don't need all the time bigger telescopes. No, we with compact telescope also, but with a good technology, we need this kind of telescopes now on our ground base. And that's why the India is coming up with a 2.5-meter telescope in Mount Abu by PRL. There they want to do this adaptive optics and optical fiber technology. Why this optical fiber? This is first is
Ashna, wait.
Sure.
What is optical fiber?
that. Oh, okay. This question I was not expecting, but okay, very good.
Okay, very in a very layman language, because
Sure. Wow, it's a nice experience for me. Thank you for this. Okay. Okay. So telephone system, telecommunication system. How this works? Yeah, it's with optical fibers. In a very no, optical fiber is something. Wow, it's a wire. Wait, I have to think about this. It is something very small device that work as a mirror, or it's like light passing through this particular wire in a very efficient way.
you can
This
say
is the
total
fiber. Yes, yes,
total
yeah,
internet.
like that. It's you will
So the
get 100%
intensity.
of yeah.
So you mean
Yes. Thank you very
uh-huh,
much for it.
So it's like it. So if you also like just give a beam of light, or maybe for very few seconds, it will like exaggerate it in a way that it creates a much more impact when it reaches the other side of that. Is it something like this?
I will not say the exaggerated. I will say that the resolving power of the telescope will
Oh,
be very much like good if we use this optical fiber technology, so to say,
I see.
because the light loss will be less in this.
Hmm. Now I understood that how it could
So
be.
and the main thing is light. Whenever we are just doing this astronomy, our main thing is light from like a object, and that is coming also so far. So we definitely need this kind of stuff where we can observe as much as light or like photons as possible. So
So I
that's
have
why
a
this.
question here.
Sure.
So as I understand optical fibers, it's like a pipe where light just bounces in this zigzag motion. It and each side of the pipe behaves like a perfect, well, almost perfect mirror. So I understand that there is very less loss in the intensity of the light, but with each this reflection, the direction of the light changes, and is I think that is that important for the telescope when we are
Yes, it is
finally
important.
making an image,
Yes,
right?
of
So
course, it is very important, because if the very good actually for this kind of thinking, when it will change the, then it might be the case sometimes in optical fiber also. So that's why people are struggling with it, because it's also again not very easy. When you say that this
Oh,
is changing, particular spectral line is also changing, so then we call it as a instrumentation error.
okay,
So this is also comes up. So it's
I
not
see.
always the, very basic that, okay, we just put this optical fiber in a telescope and done. Oh, wow, we are good. No. Actually, also we say that light loss is very less, but when you do in a ideal case, everything is wow. But when you do practically, it's always the problem. Because the thing is, light loss is minimum, but then the thing is the fiber. If you see on like that picture, the core of that fiber is also very small, and you need all this information in this particular core. That is the challenge. Because if it is going like outside this core thing, then we'll again missing this information from this our universe, and
I
then
see.
again it's no use.
So it's a bigger instrumentation error in the case of optical fibers, and that's why you are walking ahead in it.
Exactly. So
So
we, and also not only this, India is also part of this TMT project, which is 30-meter telescope. It's a world biggest telescope on the earth, like. And USA, Canada, China, Japan, and India are partner of this.
So can you quickly break down what is this meter? You said that 2 meter telescope, 1 meter telescope, now the 30 meters telescope. What does this mean? Like, what is the meter of telescope? Is it like
It's
diameter of the?
it's a
is
diameter
it
of the mirror mainly, not like it's so big like this. No, it's mainly the diameter of the mirror. As
Okay.
so?
per se, it's a 30-centimeter telescope or 2-meter telescope like that.
So it's a concave mirror, right? And is it? So the mirror is a concave
For
mirror, right?
this, oh yeah, for this, how, like, depends upon like what kind of a telescope and where are you using. It's concave, and always they are using some different kind of mirrors as well.
I see. So, well, regarding this optical fiber, everything that gets, well, I know about only two kinds of telescope. One, there is a concave mirror, and other, there is a convex lens. So, assuming the case of convex lens, and so everything that refracts from this lens has to land up in the optical fiber, is it? That's how it's somehow used.
Yes.
Oh man.
Okay, it's a very technical question. First,
Yeah.
Ashna, tell me
Yeah.
what is a simple build-up of telescope? I mean, what is a simple
Yeah.
build-up of telescope? Okay, it has a lens here, it has this here, it has this here, or something like this.
So mainly it contains of like a two mirror. It's also like depends upon, we have different type of telescope type, like Cassegrain telescope or like a Coude or something like that. So it's like a two mirrors or like a lens. It's like primary mirror, basic mirror, the light focusing on this, and then it's just coming on the second mirror, and then it is coming us to us via CCD. It's via
Analyzer.
our, yes, our eye, but it's not now we don't use this our
We use the
eye, but
camera.
we use
The
this CCD, charge
AI,
coupled device, so that just collect the photon,
AI-based analyzer.
and and then we just get this information.
Okay, so one there is a observer lens, and second one is a objective lens, right? So there are two
First
lenses,
is primary, second is secondary
primary and
mirror.
secondary.
Yeah.
So what is the
Yeah, sorry,
function
I
of
don't,
both of
this
it?
is this, sorry.
What are the function of both of this lens? Like, what is the function basically? If you remove secondary lens, then what? Like, then what will happen? What is the function of it?
Okay,
So primary lens is basically
so
to.
primary mirror is, okay, so light is first coming out that particular mirror,
Mhm.
then it will go on like on secondary mirror.
So what will it refract, or how it will be?
It will first reflect on the secondary mirror, and then it
Reflect,
will go
refract.
yes, refract to this secondary mirror, and then it will go to this our like optical lens or like a CCD part.
Mhm.
So what, like, that's why we need some secondary mirror also,
Okay.
always. Okay,
Okay.
I will not say always, that will be too much, like, okay, but yeah, that's why you need a
And
secondary mirror, so far as
okay,
I know.
and I have a very simple question now, very inquisitive. What is the mirrorless technology? Because I am a photographer. So I already know a bit. But I would love to know it from a expert who is expert in the
I will
skiving
definitely
and
not say that I'm expert in this. Whatever you
better
say,
than
call
me.
it as
I just have a Canon lens, and that's how I try to shoot the space. But like, you have a very wide technology. So can you explain exactly what is different and why mirrorless is better? I would say I don't know, but I find
it's not
mirror
about, I
really
would say that
good.
it's
I
mirrorless or
really
something.
find I really find my camera when it is with mirror really good. I don't know the like perceptions, but what is this mirrorless?
Okay, so again it's different upon as per the different science. Okay, so it's like always you have to think about your question, what you want to answer, and then this particular instrument work. Like this mirrorless also, I will not go into this mirrorless thing because yeah, it's very vague in my mind also. But for example, let's say you want to do astrophotography, so that's why you use this your particular phone camera, let's say, and you use this particular ISO properties, and you use this particular exposure time. This is your science question and you want to deal with it, that's why you're using this phone camera. Now we want to do here something different, so here we are using mirror because we want to do something different science with this particular uh, instrument. So that's why we come up with this kind of a building structure, so to say. So it's always depends upon what's your open question, what's your science question, what's your project question.
Okay, so it depends upon that.
Exactly. It's like even with the phone camera, if you want to do the Milky Way photograph,
You can do it.
you can do it. I also did it. So that is possible. The thing is, you have to change your exposure time. You can't just do like Milky Way and like a moon with the same exposure time, with the same ISO, or with the same like other parameters
No,
or like
that's not possible. Yeah,
options.
yeah.
That is this thing.
So it changes with respect to each and every
Exactly,
lens or
exactly.
each
Moon
and
is
every.
closer, craters are like so light is like so much. So then there you don't put like 30 seconds of exposure, then you will be done. You will find only like white thing in your astrophotography. But at the same, Milky Way is so far, so you need the whole Milky Way picture in your this astrophotography. Then you need good exposure of time, so that so many photons like light can come to your lens.
Okay. Now I think Himanshu can jump into his question, a bit technical question, and then maybe Ariba also has. No. Okay,
So
maybe
actually,
Himanshu.
I was thinking about your question, the Haria, is it? So your question was, what is the purpose of the first mirror and the second mirror? So I was just
Yeah.
thinking about it and going. I'm not really into this. Well, I don't specialize in this field, but I think the size of the first mirror or the lens, that is the size of the telescope that is mentioned, and the goal is to collect as much light as possible because these objects are very far away. So we want to collect that light and sort of increase the intensity of the image. But for the
Mhm.
second, I'm not so sure. Well, maybe to magnify the second one, we want more light. If we magnify there, we won't get intensity. So the first one
Um,
tries to intensify. Well, going by this
Mhm.
is my explanation from first principles.
See,
Please correct.
looking at a simple microscope, I could say I don't know about telescope setting, but what I personally think is I would say it's like magnifying the objects.
I will
Yeah,
say that
microscope.
it's because to extend your light path or like um or to redirect your light path. I will say
I
like
see.
that for like secondary mirror, that will be
I
the
see.
useful. But as exact term also I have to come up with this in mind.
I
I
see.
can't like say right now because it's for me it is very like okay, we use this mirrors. I never thought of that, but it's actually very good. Actually.
So for a scientist or for a researcher working in their own field, it's like very difficult to explain what exactly things are.
Sometimes it's
Yeah,
yes, I
yeah,
totally agree, and that's why I love this kind of
yeah,
this experience,
yeah.
so that I can also learn about my field in this way, like I never thought of, because it's so normal we normalize some stuff. So for us, it's so normal that we don't even realize that, oh, okay, this is, this is kind of this thing. It's
I
very
see.
basic concept, but yeah, we don't, yeah, because we overlooked, you can say that.
Hmm. Hmm. Eh, Okay. So, yeah, yeah. So,
Sorry, I'm not seeing in a chat for the questions. Sorry for that.
no. I think we already have few questions
I
prepared.
have.
So,
Oh, okay.
okay. Yes, Himanshu, go ahead.
Yeah, Ariba
I have
also
one
raised
question.
this, and so I can just say, seeing those messages. But yeah.
Yeah, Himanshu, go ahead.
Okay. So I was just thinking about detecting these exoplanets and the requirement that they need to be in the same plane. So that is for the optical kind of observation, right? See,
Yes.
other is this spectroscopy, and so this. Do we need to set up more stations, or so that we have more planes accessible, or
No, I don't think
how?
so. It will work like that. Uh, no. You don't need like for like so many stations so that you can observe so many stuff. It's mainly like with the northern and southern hemisphere you can find your object. So yes, we definitely need this kind of stations. Like we have this big telescope, but which is in southern hemisphere. Means if you the whole world is like this globe, we have this north part and south part. So some objects which is in north and which is very important, you cannot just simply observe with the southern telescope. So that's why we need, you can say that, more like stations or like telescopes.
I see. But for the exoplanets, they need to be there in the exact same plane, right? This star that would come in between the planet and the light would sort of go on and off from the star.
That is
That's
one
if.
particular, yes, but that is one particular system, star and the planet system. So when we are doing
Yes,
this
yes, yes.
exoplanet search, we always go for the star system thing. So then it will always satisfy the next criteria, the plane
Always, right?
criteria.
So it's like you have to
No,
go through a
no,
checklist. That okay.
that's not necessary, is it? Is it like what if? Uh, well, I'm imagining it like this dartboard. So there is a circle. The center is the star, and the planet
Mm-hmm.
could be revolving in the circle around it. So then
Mm-hmm.
there would be no change in the light. So we won't be able to see the planet because it's so far, and there is no change in the light of the coming from the star.
If it
So
is like compared like reference to us, it is moving like this, then we can see. But if it
no,
is
is
moving
it?
like something
Hmm.
like, yes, exactly like this 90-degree to us, then no, we cannot see that. But then with this kind of, you can also go with the direct imaging or with the gravitational like a micro lensing methods.
Okay.
So we have different methods, not only two methods. We have so many methods, and still we are missing out some more methods to find those planets, exoplanets.
Okay.
I see. So what Ashna told earlier as well, I could relate to it. That sun is also moving. I mean, a star is also moving. At the same point, the exoplanet is also moving. So in the most of the cases, we I mean, you might be seeing some changes uh, in the spectra. I would, I would, I would suppose that because the whole system is moving.
Yeah.
Okay, so I think Pushti is now taking this ahead. She's asking that.
Also, there is one more raised hand from like
Somalia, yeah, go
India.
ahead.
Sure. We just look from the telescope. In that, we do photometry, spectroscopy, all these other methods. No, it's just a light. And it's not from exoplanet, it's from star. Uh, no, it's the same thing. It is the same thing. It is coming under this EM, the whole spectrum range. The only thing is, but then from that whole range, we can't do with this one particular instrument because we need different instrument for that. Not instrument. It's like X-ray. You cannot observe from like ground-based telescope. So that's why what particular wavelength range we observe from Earth, we call it as that particular optical. We found this exoplanet in an optical range, like that we sometimes say. But that's not that it is like only emitting, it's an exoplanet. It's the same. We just only found this particular signal in an optical range right now, like that. Okay, so if I understood correctly, so forget about everything. This how to say this exoplanet optical range. Exoplanet is there. It's like our body is the same only, just that in like this at what scan mirror, the infrared, or how they say this on the scan. So there with they found only like heat part of our body or something like that, or like X-ray part or something like that. But in optical range, I'm visible like this to you with my this blue color t-shirt and all that. But I am the same. Only you are seeing me with X-ray or with infrared or with optical. So you can see my certain part. Like, in optical I'm this, in infrared I'm this, in X-ray I'm this. But I'm the same. So how you call it? Like you saw Aashana, but in optical range. So Aashana optical range was looking like that. But in X-ray, Aashana was looking completely different. But Aashana is the same. The body, the object is the same.
This was like very beautiful example, brilliant example. I would say
I
that
just
over.
got it now. So yeah, I
It's
hope
so
it
good.
is clear to you.
Yeah,
Familiar.
now it is.
For me also, it's new to me to explain in this way. But I'm trying my best to make you. Yeah. Oh, I can relate the same. For me, biology is always like that, and yeah, I have to go through very like basic stuff, and I also ask, yeah. So
Yeah.
it's okay. You can still ask me if you are not clear enough. I can still
Uh,
explain with a different example.
you can come up later on with some good examples. Okay, so for now we need to like move ahead in this discussion. And yes, Ankit Prakash is wanting to ask a
Hello.
question.
Yeah. Hi, Ashna.
Hi.
So, first of all, I think it was very good. Being from almost similar field as yours, so I think you explained beautifully.
Thank you.
So,
Thanks a lot. I was so nervous. Thank you for these words.
yeah. So, I wanted to ask, see, while you are detecting exoplanets, so you have asteroid belt in between, then you have something Kuiper belt. You might get into way of the Oort cloud, or there might be some cosmic ray interferences. That is very less likely, but obviously that will create some noise or background in the spectra that you get. So how do you reduce that to get the exact spectra or the thing you want to process? So how do you do that?
Okay. So for this, I will say that for astrophysicists also now programming is kind of oxygen. So we have to deal with this kind of stuff with the coding. So then we know that this particular planet or like a star behaves like this with the Gaussian profile. So
Okay.
we fit. Okay, don't, yeah, Dhairya, don't. Yeah, I can see your hand, and I'm like, okay, shit. But maybe he can understand Gaussian profile. Okay,
Yes, yes, I understand that.
Just go ahead. Just go ahead. Just go
that's
ahead.
why yeah. So it's like we have not only this, we have noise of like instrument, we have a different noise of like atmosphere, our even our water vapors are also problem for us actually.
Yes, yes.
So this all kind of stuff we deal separately with different part of let's say data analysis or like with a coding.
Okay. So I mean, I meant to ask, do you have a library for that? Something
No,
from
no,
which you
we
can
don't
refer
have,
to, or
unfortunately, we don't have a library for it. Okay, some come up with a particular coding, one particular code that used by some, or some just do by themselves. So I use my own code. My colleague use others code, which was already like done work in a similar way. It's like for okay exoplanet or like for some particular signature, this code is working. So then the other can use that code. But sometimes it's not the same code, so you have to come up with the new code. So I also write my own code and I just work with that. And then also you have to my supervisor also check twice thrice that whether we are getting the same or whether we are just doing the again the false thing or just bullshit thing. So yeah, it's not very, it's kind of this kind of a process.
okay. Thanks a lot.
I hope it's clear to you.
Yep, yep, it's clear.
Okay, it's like similar thing that everyone deals with. Even we deal with coding sometimes to eliminate our noises. So I work with facts, or I work with sometimes mass spec or something like that. Then yes, we reduce the noise like this, like pre-made programs. And then since I'm a biologist, I don't know coding,
Yeah, yeah,
so
exactly.
copy paste.
Well, for me it was very tough when I also had to learn coding. Like after coming to Germany, I heard this word Python, and then I'm like, what the hell is this? So it was so
Python
tough
was
for
made.
me to get into this business because yeah, I never heard about it, I never saw it, or I would never did this, but this is how it works, it seems.
I see. I think Ariba also has a
Yeah,
question.
there is then, yeah.
Hi Ashna, hi everyone. I actually do not have a question, but I just wanted to say thank you to Ashna for this session because I don't have this background. I'm not from this background at all, but I'm interested in this topic, and a lot of questions really helped me because there was like she somehow made it so basic that I could also understand. So I just wanted to really say thank you to you. I do not have a question, but yeah,
Thank
Ah,
you,
okay.
thank
thanks
you
a
so much.
lot, it means a lot, thank you.
Ashna,
Okay,
you
thank
have
you.
many, I would say, many people who really wants, I think, a second session with you.
Whoa,
Definitely.
okay.
So, Ankit, can you quickly introduce yourself? Like, if you not don't mind, then would be
Oh,
like
yeah,
really.
sure. So I'm PhD student at PRL, and
Okay,
I'm working on meteorites specifically,
wow, that's
Mhm.
nice.
early solar system processes.
Yeah, yeah.
So I just have a very quick question to Ankit. Okay. So, many people say, like in biology especially, I'm getting a bit out of this field, but I would also keep a connect to today's topic. So what I want to ask is, there is a theory that is a spontaneous evolution theory, that is that life came out from outside, maybe as a form of meteorite or something like that, which came from an exoplanet, maybe not, or from place where it had some organism, and it traveled all through the space and then came to Earth, and then the spontaneous life evolved. But I don't think this is, I would say, true, because when anything travels, even from, maybe consider that there is a stone or something in anywhere, so even it erodes, or it loses its signatures or whatever, and this is something like living organisms, or I would say some living entities that are traveling through meteorites, and that too in a space where there is no oxygen conditions or nothing, just dark space, that are traveling for millions of light years. So how would you actually uh, tell me, Ankit, that like how exactly this works and what do you look for? Because I was just wondering on this question one day.
Okay, so you see, meteorites, there are again different types of meteorites, and they have all different compositions. So they have organic molecules, and you're right. Obviously, they'll not organic molecules are there, but there is no signature of life, as you say, the bacteria or something. Because again, you see temperature there, uh, there it's not habitable enough. What I feel. So you usually don't get organic signature on meteorites, but you get organic molecules. Like you see, I think amines, amides, they are considered to be building blocks of organic molecules. I think you might know that. So
Yes,
they
yes.
have signatures of that. They have complex organic compounds. And again, my colleagues are studying that also. So that part survives. So what I feel is if these meteorites containing organic compounds, if they fell on Earth and further they got suitable environment, like greenhouse effect was started. I think the greenhouse effect started around 2.4 billion years ago on Earth. So again, what I meant to say is when you get suitable conditions, I think it can grow. So it is somehow connected, I think.
I see. But I mean, yeah, it could be possible that there are some organic molecules as such, but I would say there are also like organic molecules, not necessarily uh, like amides, amines, or maybe any getting any carbohydrate or anything could be just a chance. I mean, there are presence of amides and amines outside as well. So you cannot just say, and maybe this could be also a possibility that Ashna, the exoplanet that you are looking for has some different atmosphere, and the the the
Actually,
the organisms that are like maybe aliens, like we are humans, we are termed as Homo sapiens sapiens. There could be something like ding ding ding, whatever. So they could be surviving in some different kind. Maybe they inhale carbon dioxide and exhale oxygen.
so
Maybe.
actually, I don't know about this thing, but even in the atmosphere modeling also, the thing is, we first go with the modeling. So we were doing this kind of cloud-free atmosphere modeling, cloud atmosphere modeling, sea modeling means where only sea. So we also, I already did this kind of atmospheric studies, like imagining that this exoplanet might have a cloud, might have a cloud free, might have a sea, and then you have to see whether this is like replicating the same with this particular atmosphere or not. So it's always like in astronomy, it's always the simulation, or even in the instrumentation also, it's always like first simulation, then you observe, and then you see whether it's matching or not matching.
So it's like we observe for our interest that whether it has what suit us or not.
It's always like
Like
open
that, I
question.
would say.
Yes, it's always like open question that we want this, but then always it works like this, that we found out something else from this. Like
Mhm.
Sobel prizes were just like
Yeah,
just been like that. We
yeah,
were like hoping for something else, and we found out completely something different.
yeah,
But this
absolutely.
is science.
Yes. Okay, so now let's just move ahead quickly on some very important telescopes. Would you like to tell a bit about like James Webb Telescope and also the Kepler Space Telescope, and like how are they significant, and like I just want to also add one more question to it, that uh, do you confirm your results with these telescopes, with the space telescopes, like
We do a
confirmatory
follow-up observations
follow?
from this telescope, means they found this particular, so like test already did this so and so, like this is, we found this exoplanet. Now follow-up observation with the same particular object we observe from our 2-meter telescope, and then after the analysis we confirm that okay, this is the one. So this is how it works. About the Kepler, okay, Hubble was the main for this field, I would say. So now it's not, but then it comes up Kepler, and it blew all of our mind because it observed more than 1.5 lakh stars. So and the stars and then the planets. So they found out so many planets and all these systems with the Kepler. And then at some point they were like, okay, we can't fund Kepler and blah 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 and all that. But still it continued. They thought that it will die, this mission will die, but it still continues. And then comes the test, this transiting exoplanet science survey. Yeah, please, yeah, check this out, okay, or survey satellite, something like that. Yeah. Then it comes this James Webb Telescope, and also in the future, we are coming up with the Europe is also doing way more great, and even India. It's just that we are sometimes very unaware of it. Like okay, India's doing on the like Ladakh, they are observing. I don't know they are doing exoplanet study or not, but for PRL, I can surely say that on the Mount Abu 30 centimeter and like they are coming up with 2.5-meter telescope, they are going to use for this exoplanet studies. Similarly, in a Europe Letospecs, so it is also mainly like next year only it's planned to get a first light. First light means when you observe for the first time, we call it as a first light. So that is also going to happen next year. That is also mainly focusing on exoplanet. We also have in Spain, we have Calaralto observatory that is doing mainly this exoplanet science business. So this is the telescope, and we have others a lot like a small telescope. So it's not like that a 30 centimeter telescope cannot do. No, all telescope can just provide their kind of information or science, and from that we can get anything like so everything is matters simply.
I see, I see, I see. So,
And sorry, one more point to cut you, that for tests, I guess go to that website if you are like you have a free time or something. They have this citizen science project also. So there you can also find exoplanet by yourself. And you can just put it as like, okay, this is by my. They have some kind of website, they explain how you can do this. But so many exoplanet on this test, they found out by this normal people like us. It's not
can
found
you
out by this.
can
Yeah.
you do it with your camera?
So test is like it's already telescope over there, and they have a data. You have to do the data analysis part. No, with the camera, no. You need to get a funding to work with the telescope.
I think I
Or
should
with
come
the
to.
camera,
I
you
should.
need very high-fi camera that is
I
way
should
more
drive.
expensive.
I think I should. I should come to Vienna maybe 3 or 4 hours from here and.
Sure. We have some students project available, so we would love to have you.
Maybe I would even fail in student project.
No, not like that. It's not about failing or passing. It's just about learning.
I think I should focus on my PhD.
That I will say that's better.
Okay. So okay. So what did Hubble Space Telescope come up? Like, what is the first telescope space based? I don't know. Hubble Space.
Yes. I guess yes.
So it started looking for exoplanets and all the space things and
It
everything.
was Hubble was not actually for like exoplanet. It was started looking for it, and by that time, so exoplanet field is a Gen Y field, by the way. So by 90s, they found out this first exoplanet, and then they were like, yeah, okay, we have this, so we just observe this particular object also in the space. Like this, it started. So it was
Okay.
not like even for Kepler also, okay, I can't say even for Kepler also planned only for this.
Mhm.
But then it turns out that okay, Kepler will also do this, and yeah, like that. And then
Mm.
TESS was actually, because it's like in name it will say that transiting exoplanet survey satellite. So it was planned for this exoplanet like that.
Okay. Okay. Okay.
What was the difference? Like, what special things were decided to keep in test rather than any other telescope? Because it was
Um,
only for exoplanet study.
I can quickly say that some resolving power or something like that, but in the detail I also have to go through this instrumentation like
Mhm.
study, like what is different from like 1 to 2. I don't have like in my mind that now, but mainly it just changes as per the science. Like Tess was doing this photometric study, so they use this particular so and so instrument to do this study like that. So it's like in India, okay, for example, in India, we have this PRL telescope coming, but their main idea is to do this optical survey of exoplanet and all that. So then they are building it like this. But then we have already in India like a liquid mirror telescope. It's also Asia's largest liquid mirror telescope. But that is doing a different kind of science that is mainly surveying galaxies of the universe. So then they made it like this. So mainly this is the difference, but in a detail, yes, we have to go and check.
Okay, I have many questions, but this question would be like really relatable. The thing is that how do you uh, point out that okay, if you want to study that exoplanet again, like okay, today night you are done, you found something, some signal, and then you're like, okay, now I cannot work. It's like continuous 24 hours of observation. How do you go next day? Like you cannot get that thing exactly at that point, right?
No,
So
we failed also sometimes. So my earlier, okay, we were not doing for the example, for the other, but for example, sometimes we just fail it. Our
you
observation
just
just
lose
fail
the
it
contact.
because we don't get that object, or we just not get enough light of that object.
So
So,
how do you keep a track of that if you want to? Because
so
like
with the, this
how can you say that in this big space, okay, this is here, or like what are
no,
the
so from this test or something, we have to find out our object, and that is like available in like astrophysical query on Simbad,
okay.
SIMBAD. So there you can find out different object and
Mm-hmm.
what suits your science.
Mm.
And then for this particular object, you have to see in another kind of a software or like a program whether this is visible from my area or not,
Mm.
and also
Okay.
on which time. In India, some object might be in the evening sky, but here then it will be in the morning sky, something like that.
Or maybe not even
As
seen.
yeah, as per the longitude and latitude. So you have to see this object is particular visible in this particular area. Like for
Hmm.
example, I am making my own observation log for the next week. I
Hmm.
have to look like whether this is at available at 4 a.m. or at 3 a.m. or at 2 a.m. like that.
Hmm. So when
This
it
is
will
how
appear in your telescope.
and then we observe, and then when we do data analysis, then we come up, oh okay, shit, we have to do it again, or we don't have to do it again.
And then how do you mark this? That okay, tomorrow or tomorrow at the same time you will use the same parameters again.
It is not like that. We just get a data,
Uh,
because we can't do an analysis just like that. It also takes some time. So we
yeah.
just take data.
Hmm.
Okay, this particular object we will take like say like 30-second exposure for so and so data, and we just statistically we just come up with the idea from like a previous results or like a previous studies. Like
Hmm.
this much data is enough for this.
Hmm.
So then we took, and then we go to next object. This is how in, because in our my telescope also, it is not my telescope or my father's telescope. So it's, we also have some particular time. I can only observe in this particular time. So we just took all this data, then I do the analysis. So it is, even I don't know whether I'm doing, so it is like enough data, not enough data, it depends.
Data sounds like a
Yeah,
garbled
it is a
thing.
data analysis or all. It's not like,
Okay.
you see very this good images and all that. Trust me, when we observe, it's nothing like that.
So
It's
it's
just a very bland spectra and like all this, all this.
I could imagine. So I would just like to ask you a question on this. That now, do you have to do any replicates as well with the study? Like you got it, and then maybe if you lost the contact, you are not getting the same data again. Then how do you prove this? That okay, this is what I found, and I am 100% sure that this is exoplanet, because like this happens with us, especially I understand that biology and physics works differently, but still the concept of science remains the same. That if you are seeing something, you need to see it again in order to prove it that okay, at least three times, 3x, n is
In
equal to
that, I
3.
can say it works a little bit different, that we have always the raw data. So we keep it raw data also separately so that others can also use that particular data later on.
Yeah, but I mean, if that raw data you do not get it again, then
Normally it's not the case, and okay, sometimes it's the case when it's orbiting like in once in a 10 years or something like that, then but then you have to wait for 10 years in that case.
okay. So okay. Now I got it, because all the system is moving. We are also moving. So it's quite complicated as you think. Like
So it's like, for example, last year it was like that there was one very important transit was coming. So my supervisor was so like in tension because that particular transiting thing is again coming up in next 7 years. So it's like we need to
another
get that
PhD
data.
student.
Yes, last year, like we have to. And if we miss it, then it's like bye bye. It's again
Mm.
coming, but yeah, next 7 years like that.
You are planning to continue?
For that, for no, we already got results for that. It's
Otherwise,
in
it would
process.
be
The paper is in process. So done with that.
okay. So what was my question is again this, that how do you? I'm not clear with my question. We are also moving. That system is also moving. Maybe universe is also moving. Some parallel universe.
It's expanding, I will say.
It's expanding or whatever. I don't know. Like it's changing continuously. Like every second, it's different. So what I'm asking is, how do you point it out? I mean, that if you want to visit that second day, the same parameters that you kept today won't be feasible for tomorrow because it's changing.
It will not changing very speedily. So it will not okay. Some minutes it will like okay.
So you
It
have to
will
plus or
rise
minus
some minute
something.
later, and it will set some minutes earlier or some minute later. This difference we will see, but in just one night you will not see so much of difference.
Okay.
Only when it is transiting thing, then
Hmm.
sometimes you see that one night it's transiting, but depends upon the orbital period of that particular object. You see that next night it's all only the star spectrum. There was no transiting because maybe the planet is here and it's not coming even the here as well behind. So it depends. But when it's like for my colleague, it was like the orbital period was 7.7 hours.
So
So
it.
it's always there. But for some
Hmm.
orbital period is like I worked with 13 hours orbital period or more than that. So
Hmm.
sometimes it's there and sometimes it's not there. But still you have to take all the data.
If it's in the morning, then
Yeah, then you can't observe.
you can't observe. Yeah. Okay. You have to like wait, and wait. Okay, good. Uh-huh.
No, physically I will be there. Not I'm clicking picture. I'm just taking spectra. So I will be in the control room, but I am observing next week means I will go there physically by 9 p.m. to opening the telescope, to be in a control room, to give some coordinates that this particular object has an address. I have to give that address to the system. Then telescope will move to that particular object. Then I need to give some parameters that I need for 30-minute exposure or for 1 hour and something. Then it will collect light. So we have AI for this, that in 1 hour, so to say, the object will move, of course, little bit. So as per that, the telescope automatically moves. We have until that much. But other than that, we have to go that physically and do the work.
So suppose
You can.
you're planning for an object imaging, which you calculated that it will come around at 3 a.m. or 3 a.m. So, but due to some space storm or something like that, it deviated its direction and it went more speedily. It came around 12 o'clock. But so your experiment would be
For
gone.
no.
It's not that quick. That's what she said, and also they also calculate the time as per that what
so
today is.
stars, it's like moon will rise up on the same time, and moon will, there will be the monsoon and all that, but moon will not affect on that phase. Similarly, like for
So
our
you can
stars,
calculate
for
that
our
time by
object.
yourself. That okay,
So
my
sun will
Earth's
not,
time.
sun will not bother whether it's a storm or not. It will rise on the same time, whatever is like there calculated,
No,
sunrise
I have
time,
heard of
sunset
there are space storms as well.
time. That will not affect the stars, so to say. Like a space from mainly for like a instrument, like in the space instrument, or like this international space station, they might get affected, but or like we can see some problems on like atmosphere or something, not like the stars. It's way more far than us, so it's not work like that. Yeah, it's like yeah, let me come up with some example that I can explain you nicely. But yeah, normally it's there, but okay, how can I say that?
Can I give an example?
Yes, please go ahead.
So
Some example,
imagine.
अच्छा देते हो.
Thank you. So imagine, do you fly kites? You do? Okay, cool. So imagine somewhere your friend, maybe, almost a kilometer away, and he's waving his hand, right? So although he's waving his hand, but the distance, you don't see so much difference between the leftmost angle and the rightmost because it's so far. A similar concept is there, right? Since the star is so far, the angle by which it changes, it could be moving at the speed of light, but still, for us, the angle would change very slightly. It's the same concept
Frankly,
applies.
yeah, this is also example, and frankly, the storms not actually affect the stars, like
Oh, really? Okay.
just like that also, because it's yeah, unless and until it's going through a supernova effect or something like that, then it will change completely. So okay, supernova effect means Dairya was saying me yesterday. I just remembering that and laughing. So it's like some star born and star die, or in the Dhairya's language, they just I don't know the even English word for that, but yeah, okay, leave it. So when the stars die, so before that process, it explode. So in that case, maybe this will affect. But my object is not that star will die. I'm not focusing on those objects. I am focusing on this object. This is like going to live, or in it's like in a living mode right now. So they don't change much. Even in stars also we have this, like we have this particular graph, we call it as a HR diagram. It's very famous in our field. HR diagram is our like very you have to know this term like that. In
Can
that
you can
also,
you can you break this down? HR diagram. What is HR
HR
diagram?
diagram is Hertzsprung-Russell diagram. Two scientists named, they found out this. So in this diagram, it's like it's temperature versus brightness, and then you can put all the stars in this graph. Means if the star is born, then that will be particular at this point. Then it's a main sequence line. Main sequence means the star is like in from like a young age to going through like a middle age to going to a old age, and then red giant phase and all that means going
But
to die.
how do we define these? I mean, we are looking at a space
Yes,
which
in
is
that
not
also,
even existing right now.
in that also it depends upon the type, like star type. So like a human, some humans are thin, some human are like average weight, some human are like big fatty humans. Regarding this also, stars also have these three kinds. Some are thin, so when they evolve and when they die, they become this white dwarf. So our sun will become a white dwarf. Middle age will die and they go to this neutron star phase. And big fatty stars die and they become a black hole.
Oh, so but
This is
how do they uh,
how
how
do they
do they
what?
know that this is a fat star, this is a not fat star?
So
Because
that
there is no yet comparison. Maybe there would be another star who is fatter
from
than.
their mass, we will
Okay.
say that we have one solar mass. Means
And
this
how do you say
particular
that a fatter would definite form a black hole? Have they
because
observed this?
yes, observed black hole and like mass also observed, and also like black hole mass is way more. It's like 12 solar mass. Means it's bigger than 12 times the sun's mass. Means
Hmm.
of course you can say that it is a big one. So our like reference point is a one solar mass or like one earth mass, like that. Even in exoplanet also we use it like this. That this particular exoplanet is like two earth mass, means it's twice of this earth mass, or it's like
Okay.
one half earth mass.
Okay. And it could be possible that, just imagining, it could be possible that, consider that a star is about to die. So it also takes all its planets away.
Yeah, that is a possible.
I mean, take its all its planets away, in the sense maybe
Possible.
that whole solar system forms a black hole. Because from here we cannot say anything that it's only a star.
Yes,
It could
yes.
be because it's a huge mass. So it's like,
It is only like exploding, and then we will get it later on kind of phase.
so
And even
it's
if some this big explosion are like that strong that for like several days, even in the daylight
it
also,
stays.
it stays and you can clearly see.
I my physics teacher told me this once when I was in 11th, 12th, or I don't know, in university or somewhere. The physics teacher told me that when there are these kind of star explosions, the astronomers really, they see in the space of very
Ah,
bright
yes,
light for so many days.
yes, it happens. And whenever
Okay.
this kind of the whole astronomy community is like, even the whole world is like exciting, it's because like you can see this explosion.
When it will happen?
Now also in 2020 they come up with this one star they were like observing, and suddenly that was some like in spectrum again there was some fishy kind of activity, so they thought that it will explode, but then it turns out that it was just a dust cloud in front of it. So yeah.
Okay, okay.
Uh,
So now I
Hi,
get it.
can
So
I
this, yes, yes, Ankit.
get more technical on this? Like, I wanted to ask Krishna, like, since you mentioned HR diagram, do you have any criteria that you'll detect a T-tary phase star or a main sequence, or uh, when the star is in AGB, so you'll detect that system? So, what
uh
systems do you detect?
yes, I personally for my project I only focus on like M type stars, so M type stars and K type stars around object. G type I want to go, but we already know that we don't have much systems around G type stars. I'm focusing in very like scientific terms because I know you already know these terms. That's why.
Yes.
So that's why I am only focusing on K type and M type so far.
Oh, okay.
Uh, so as now, Daira has already wrote one question and like we have read some news that there is a super Jupiter 7 to 8 light years away. So like, do you confirm it? Yeah.
I also heard the news, but the data is not yet with me, so I can't say that I confirm or I reject. Yeah, it turns out that yeah, we have some this kind of a system, and people are doing research on that. But yeah, it's not my object, so I can't much comment on that.
So a very curious question that how fascinating you feel to work in this field? Like what gives you thrill working on exoplanet and everything?
For me, it's always like, okay, not always. Sometimes I also feel like, I don't want to do this work because I'm so tired, not because of I don't like it, but yeah, day and night working mode. I feel it personally so good because it's something that I feel it that we don't know yet, and I'm on the way to find out something very, very new, or if not new, very interesting. So because of this field always like fascinating me like anything. Whenever I just observe at the night sky, I see the Milky Way and I see lots of stars, and I feel like, oh my god, like we don't know anything. We are like very, very, very small in this whole universe, and we don't know anything. So this main thing is fascinating me a lot, to just get a little bit more knowledge of this universe. And also I like this instrumentation building and all this business. So yeah, that is also fascinating me.
So looking at the Milky Way daily.
Sorry.
Looking at the Milky Way daily.
Yeah, yeah. If the weather is nice.
Germany's weather is going bad now. So I mean, you already planning experiments for next week, but how feasible for you it would be? I mean,
So far,
have you like waited for like months, and then if there is some, consider there is like you said that okay, there is one transit in 7.5 years once, and, and the atmosphere is not bad on the same day, and then how do you
then
deal with
then
it?
it's gone actually. Unfortunately, then
It's
it's
gone.
gone.
You cannot do anything.
I cannot do anything. It's not in my hand, and that's why it's just fascinating for me that we are too small, that we can't do hell of it. We can just like do like this, and we just sit the whole night. I just sat like this.
Okay, if sometime there is something, if sometime there is something, if I get something, if there is a bit like
Exactly,
somewhere
exactly.
there is no
So
cloud,
you
and then I
have to
can
be
just
very patient. It's like so many nights were like that I just like until 3 a.m. it was nothing, and then it was suddenly clear sky. So I got at least 2 hours of data, 3 a.m. to 5 a.m. So it's like that. Or sometimes it's like early in the night you got, and then it's always like rain or like clouds or something. So you can't do anything.
I see.
That's why we need a less light pollution, and good night sky.
India has good night sky almost many days, but light pollution and atmospheric
Yes, yes. In
pollution.
India also we have very less sites where you can do like good science kind of
No.
observations. Yes, in Ladakh they are doing very good. Also in like Kavaluru Observatory they are doing good. But yeah, mainly this light pollution thing is coming up everywhere.
So pros and cons of each places. So
Yeah.
like India is a good in a good zone. I would say where atmosphere is good, but then the pollutions and everything.
Yeah.
I see. I see. So like if we don't have any further question, Pushti, anything? Okay. So in a very short, Ashna, I just want to ask you some conclusion. So
Let first Pushti
I
ask at least.
okay. Sorry.
No, I don't have.
She just unmuted herself, that's why.
Uh, I don't have any questions.
Okay. So just to conclude quickly, like we are coming up with another physics topic itself next week, I guess. It's related to physics only, and it's like from PRL only. So maybe we would have someone, I think a postdoc or someone who would be talking a bit on this Nobel Prize that was recently awarded, and we will try to break down and decode it a bit in a language where layman can understand, or maybe I can understand. For physics, I am a layman, so
Everyone is layman in other.
everything I
Even
would
in
say.
astronomy, also I am layman in like when it comes to radio astronomy. So my colleagues when
Yeah.
sometimes work and I was like, okay, what? I don't get it because I never worked in it. So I literally don't know anything about it. So it's like that.
Yeah, same happens with us as well. So like I work on viruses, but maybe if there is someone else who is working on some other virus, I don't know. Sorry. It's like sorry.
Yeah.
I cannot say anything. Yeah. So yes, we are coming up with another physics topic, but we need suggestions from physicists. We have Himanshu, Ankit, and Ashna. Like there is no physicist. Okay, with like there are very less physicist people who actually do stuffs. So I see Bhargavi as well. She is interested in space. So yeah, but I know about her, but I don't know who is Naisha. Naisha, are you physicist or I don't know. I mean, like there are very few people who stay till end. There are many people who join early, like 20, 30 people who join in the first time, but
Okay.
then like gradually they turn up to like 11, 10.
It's okay. I always like I am right now listening this podcast of Huberman's lab.
What is that?
So Huberman's lab. It's a neuroscientist.
Uh-huh.
So on Spotify, it's a free podcast, and it he tells about this how these hormones and our body and all this works. And I found it very interesting because it
Can you,
he gives in a very simple language. So I love it
can
personally.
you, that's great. But can you tell me some podcast which is related to this
Okay,
astronomy
for
and stuff like that?
astronomy podcast, yes, I do have.
Very easy ones, but
Yeah, yeah.
like
Wait,
where
I'll
I can
tell you the name, but
understand.
they have some for sure. They have, I guess, physics. Mm,
Maybe you
Yeah,
can
they have
send
this
it to
physics
me.
called a weekly podcast.
Maybe you can send it to me later on, and then
Sure, sure,
maybe we will
sure,
write
sure,
down and the email for
sure.
who all the participants will just write it down and email to them, or maybe you can just paste in the SciChat group. Everyone
Yeah,
will
yeah,
get it.
sure, sure. But
So
for as
Ankit,
this Huberman says, like thank
yeah,
you for your interest in science. So how many is joined? It's not a problem.
yeah, exactly.
Interest
So
matter.
Naisha, if you would like to just introduce yourself or okay, so we have a feedback form. Maybe whosoever is interested, please fill it and give us the suggestions of topics. Also, write about yourself, your own topic, so that we can also call you on side chat. Maybe Himanshu, Ankit can also
So yeah,
come and talk
yeah,
about
actually,
it.
and not a question. Actually, so I found this talk very interesting, and although I work in a very different field, so I work in the intersection of computer science and biology.
Hey, you
Uh,
work in biology.
Wow.
yeah, so
Which
I
field do you work in?
so I am okay. So I'm exploring one network biocomputing. So we are trying to do computation using uh, while using biological mechanisms. That is one thing that I'm pursuing.
So it's like, can you find a interaction between RNA and protein by bioinformatically?
No, so that that
Yes,
is
then there is an
so I'm
interest.
working on
Okay.
two projects. One is
Uh-huh.
given a maze, we encode computer science problems as a maze and then use biology to solve this maze. So
Oh,
that so we are using microtubules, and so I'm from computer science background, but I'm using it here.
let's see.
And other is we are trying to simulate biology in a restricted mathematical language, so that there are
Biomodeling.
some biomodeling. Yes.
So you can
So
model a cell. Not
well, that would
exactly, but
be
maybe.
that is the
It's not
dream.
exactly,
That
but
is the
maybe.
dream.
In very future, that if you can model a cell, you can make a cell.
Well, let's see. We are trying to get the basic tools right. If we get that right, we can make build more.
Like an exoplanet, we are still finding the habitable
I
one.
know, right? I mean, what I personally feel is the space is so much related. I mean, we are the same. We are the part of same stardust, like somehow we are.
Yes. Yes.
So what I feel is that whatever mechanisms there are, they all interconnected with each other. I mean, if we study biology and maybe include some concepts in okay, I'm not disrespecting any field, but getting some space knowledge and then putting into some atoms or something like that, that's what was done, right? I mean,
I want
So
to
that's
add
how they
one.
prove.
We have this astrobiology field also.
I really want
People
to get
do
into it.
PhD in this.
I
So
want to.
we have
That was my dream when I was in my like bachelor's or master's. I had a talk of Professor Sudha Rajmani. She is a very well-known astrobiologist in ISER Pune, and she was like my okay. I want to go here for my master's thesis, but then my interest changes. But still, I want to go to NASA for some astro. I don't know because in India there is nothing like astrobiology. Like ISRO is not focusing
Yeah,
on it.
they so far not yet. Even in India, exoplanet also recently started.
Mm.
Let's say like 10 years back. So, but maybe it will come soon. Maybe because
But
now people are doing
I
good.
really want to work in the field of like astrobiology. I don't know how, but
But it's there. First, you finish in PhD in biology, then we can come up with one joint collaboration and raise some funding.
Okay. Well,
something I could imagine. Okay, okay. So let's finish. There is a
Yeah.
feedback form. Please fill Himanshu, Ankit. You guys please fill it. Just write feedback that what topic you work on. So we'll just have it, and then we can just write you an email. So and Himanshu, how is the case in Israel? Is everything fine?
no, I'm still here in India. I was supposed to actually join this year. Actually, I was supposed to join
You
2 years ago,
you were supposed to
but
join. Okay.
first COVID happened, and now
And then now
this
this, I
war
would
broke
suggest
out.
start applying to Germany.
Well,
Freiburg.
I'll,
Freiburg,
I'll
yeah, I mean Freiburg is like hub for computational biology, I would say. Because these people work everything like they connect everything with biology. I mean, even they develop this biosensors and everything which is like related to biology only. Everything like biomodeling and everything they do it here. So
so
Freiburg is like you can
I love actually,
start.
to be very honest, I love being here in India. It's just that I found something very interesting, and that just
That is so good.
captured
Even
all my
that
attention,
is
and I just
I
that
can
was what I
totally
decided.
relate, and
we
yes, I
can.
feel it.
Ashna, can you go there with khichdi or stuff like that to eat in your control room? Because how will you spend your night? If you miss
In a
something,
telescope site, the food is not like where the telescope
Of
is
course.
is
yeah, obviously
there
that
the
is
food is not
allowed.
allowed. But on the control
Otherwise,
room, yes.
there would be a signal. Oh
There
shit!
is
I saw khakra.
yeah, yeah, there will be of signal of yes, of course. If you just sometimes if you are not even allowed to go to the spectrograph room because even the temperature of my body will also affect in our observation.
Oh.
So and even in the daytime, so that room is locked for all. Like you cannot simply go in that spectrograph room. And also in control room, we have the kitchen also on this middle floor. Like telescope is on the top where we have a control room with a kitchen, washroom, of course, and we can have a tea, coffee, everything over there. So yes, people actually loved here gatia because when I was observing one time, so I went with our Indian coffee and chai and also gatia that I just ordered from here from Indian supermarket, and they
Gatia.
loved it.
Everyone doesn't know gatia.
Okay.
It's a
Oh
Gujarati
yes.
term.
Oh yes. I'm sorry. Yes. It's a
Explain.
Gujarati snack that we just have it with the coffee or tea. But it's very like dry, made from chickpea flour.
Hmm.
So yeah, people loved it. Like scientist from Russia, he loved it that much that I have to order for him the next time separately.
Oh,
Yeah.
I mean, that's good. Yes, even my friends here, they really love like
Yeah,
when
so
we do
in
microscopy.
observation room we have sometimes when the cloud is coming you cannot sleep, so we sometimes like talk about science fiction movies or like this eat something, and it's fun always. Why you come up in the astronomy, we also with the professors and sometimes students also join, so we talk about this all. Sometimes philosophy, sometimes movies, sometimes rubbish.
What I really feel is that like when when I was thinking it that okay, the star that I'm looking is not what it is now. So it's like I think that exploded my mind to have this session actually with you. Like it was a very random thought. I was just sitting and then I was just observing some things and star, and then I was like, okay, this is star is like very far away, like billion light years, and I'm looking at this star which was 1 billion years back. So that's how I then just made you a call, texted you at the night, I guess. I don't know, but maybe next day that, hi Ashna, just call me when you're.
Yeah, thank you very much. I hope that people, I'm not that wrong, and people maybe understood little
That's
bit
fine.
from my blah blah. But thank you very
Let's,
much for inviting me here. It was really nice experience for me as well to explain my topic in this way. It was wonderful.
Yep. Okay, then I think we could end this session, and Ankit and Himanshu especially, please fill out the form so that we can reach you, have you over
Sure.
SciChats, because we are also like, we don't have any physicist. Like now we have Ashna, we have you guys,
I'm
we
not
have one
physicist.
more friend.
Me too.
I'm
I'm
nothing.
also
So
not a
far, I'm
physicist.
nothing. That's why.
Sorry, Ankit.
I'm also not a physicist. So basically, it's interdisciplinary for me. I'm a geologist working
Oh,
in this field. So it's
geologist. Good. I mean, yeah, I mean, something which is apart from biology, I would say. Okay.
I will say I have some knowledge of physics and astronomy. That's what I count myself as. Simple.
That is so
So
modest of you, Sashna.
No, I don't want to. You know, it's so much responsibility when you say physicist or astrophysicist. That's why I don't call myself this, because it's then you have to be so much responsible, and yeah, it's scary.
Okay, fine.
so
So we are trying
so one thing I
to.
want to say. So well, I see there's a very interesting group here, and all of you are exploring such interesting subjects. So if you need a computer scientist or a programmer, feel free to reach out to me, and
I need
I'll be
I
actually
helping
will
you.
surely reach out to you.
Yeah.
Sometimes my code
authorship देना
error, my
पड़ेगा.
code is not working, and it's like, oh.
Okay, sure, I can help out with that. But,
Authorship.
more. Hey, if I build something, no, if it's something like a code error, that is of course not. But if I bring my own idea to the table, then of course, nothing. I
Yeah.
wouldn't expect
Yeah.
anything. Yeah,
I
fair.
need some. I
What's
need
yours
some.
is yours.
I want to develop a program. Actually, it's already available, but I don't know why. So it's a program to analyze images.
So if it's already
So
available, why not buy it? Why build it? If it's already available, then
my boss is like,
is he?
Again, funding. Yeah, our
Yeah.
supervisor
no,
always
it's not
wants,
like that. I mean,
don't
my
buy.
boss
Just
is really good. My boss is really good, so we have good funding, so that's not a problem. But actually, I want to learn this. I want to learn how to develop this. Like it's like image, and we get an image where there are like patches. I would say, like there are different lights coming. One is a white light, and there's like blue light a bit. So there is a patch in between. Like if there is infection, so there would be a patch in between, and other would be like live cells. Okay. So there is a patch in between where there are no cells. So it would be just the white light coming. So I want to develop a program which could like differentiate between this light intensity.
that is
And
possible with the coding.
yeah,
This
I
doesn't
know.
sound very hard.
Yeah, but
Yeah, that is
for
possible.
me, who rarely know, who was like Python means virus means some virus. So
Okay.
for me, it's difficult. But
So
now I'm learning a bit
so what would be
from
interesting
you.
for me is well, for my master's, I focused only on computer science, and then for my PhD, I moved towards this intersection of biology and computer science.
Hmm.
So, jumping into this new area, I see a
Hmm.
whole new set of problems that I could contribute
Yes.
to.
If
So
you
that
if
is
you
good.
have problems with biology, then you can always.
Uh,
I would love to help.
sure, I'll reach out to you. I'll make a note of that.
I cannot tell you in a computational way or mathematical way, but I can tell you a bit in a biological way.
It's okay.
Where
We
did
can
you
have
do your masters?
ISC.
I was also there for my thesis.
Oh, is
So
it? Okay.
long back, 21,
Acha.
2 years back.
Yeah, I had left by then. Yes.
Oh, you completed your masters before that,
Yeah, I completed in I think 2018.
2018. Huh? That's really
Yeah.
good. So
Yeah.
that's good. Okay, then I think maybe we can end, or if you guys want to chat something else, then we are open. But uh,
I think
well,
I'm gonna go and eat something.
So thank
I have
you,
to make
thank you,
some
Ashna.
chai.
Wonderful talk.
I have, yeah, I have to make chai, and then I have to go to lab. So to
All
set
right.
up some
Have a good day, all of you, and thank you.
Thank
Same
you,
to you,
and same to you
Himanshu.
guys, and thank you for joining.
Same to you,
Bye.
Ankit.
Bye.
Yeah, everyone. Bye.
Bye.
See you all. Yeah, maybe next week we'll have weekend. Next weekend I'm not there. So
So this was the first time I attended this. This link popped up, and this is so
how
interesting.
did you get it? I'm just curious.
Just a,
How did
just
you
a
get it?
random email. I don't know how I got it, and
Just a
how do
random
you
email.
have my email address? But I'm glad you did. So,
I don't know. Do I have an email address? But I don't know. I mean, that's not managed by me. That is managed by the website and
so,
our
who-
technical people.
so whoever manages, please say thank you to them from my side.
Yes, thank you. That's
Thank
that's
you.
good. So accidentally people come. I mean, everything happens. Okay, great. Thanks, Ashna,
Thank
for
you.
accepting my invite suddenly. Like, yes, I would be happy to come, and maybe sometimes we could have another topic when we
Sure,
have
sure.
like.
And thank you for motivating me, like because I was so nervous and I don't want to do that, but yeah.
I
Finally,
told you, don't worry. I would be there to extract the information.
yeah.
So you don't have to worry. It's a job of a moderator or the person who is
Also, thank you to Pusti.
Pushti. Yes, Pushti also did. It was her first time she attempted,
Yes, yes, that's why
and
Pusti finally we did it.
Thank you, thank you. Same
yes,
here. It was very nice interacting with you again.
Thank you, thank you.
yeah.
Okay,
Okay
then
then.
bye guys.
Goodbye. See
Bye-bye.
you
See you.
next time. Yeah.